Hi, my name is Talia. I'm a high school senior and I love teaching others about chemistry and math. This YouTube channel is a supplemental resource for anyone who may be needing some extra help in their chemistry classes. This week, I'm going to be starting a new unit on stoichiometry, and I'm going to begin with talking about mole ratios and basic mass-to-mass stoichiometry. So I hope that if you need help with those topics, you will keep on watching. Without further ado, let's get started. Okay, so the first topic I'm going to cover is mole ratios. And mole ratios help you calculate the moles of another compound in a reaction that would be reacting or produced given the moles of like a starting reactant in the reaction. So you use the balanced chemical equation to determine the moles of each substance in the reaction. And the coefficients give the proportions of each compound in terms of moles. So in the reaction, 2Na plus Cl2 yields 2NaCl. Our proportion is that for every 2 moles of Na reacting, there's 1 mole of Cl2 reacting and 2 moles of NaCl will be produced. And we got that from the coefficients. And there's a 1 in front of the Cl2. So the coefficients serve as kind of a guiding force when making calculations, whether you're converting between moles and moles or moles and mass, which we'll get to later. They help determine the ratios of compounds in the reaction. So you can use these mole ratios to convert between different substances. So when you have a mole ratio, the amount of moles of the given substance serves as the denominator, and the amount of moles of the substance you want to determine is the numerator, and you include the coefficients when doing a mole ratio. So let's say we're using the same reaction as our first example, 2Na plus Cl2 yields 2NaCl. If I'm starting with 5 moles of Cl2 and I want to figure out how many moles of NaCl will be produced, I am going to take the moles that I am given, 5 moles Cl2, and multiply it by a fraction that will help me determine the moles of the substance the question is asking for. And in that fraction, the ratio of the product that I am trying to get the moles for will be on the numerator, and the moles of the substance I am given the moles for will be in the denominator. And just a reminder, these moles are a ratio. So in the reaction, there are 2 moles of NaCl per 1 mole of Cl2. So what I'm going to do is multiply 5 times 2, and I would get that there are 10 moles of NaCl produced. So again, I multiplied by the ratios in the reaction, and this mole Cl2 will cancel out because I have the proportion of NaCl on the top. So now we're going to do some practice. So in the reaction, 2Fe2O3 plus 3C yields 4Fe plus 3CO2. If 0.35 moles of Fe2O3 react, calculate the moles of carbon reacting. So I'm going to start by writing 0.35 moles of Fe2O3. And remember, the units for moles is just MOL. And then I'm going to multiply by my conversion fraction. So on the top, I'm going to have the ratio of the compound I am looking for the moles of, and that is carbon. So I'm going to have 3 moles of carbon per 2 moles of Fe2O3. So now I'm going to multiply 0.35 by 3 and then divide by 2 to get 0.53 moles of carbon. And remember that significant figures still apply. It's also really imperative that in these mole ratio calculations, you have a balanced equation. So always make sure you check that your equation is balanced before you do any calculations with ratios. So now if we have 0.20 moles of carbon dioxide produced, calculate the moles of Fe2O3 that reacted. So we are going to start with 0.20 moles of CO2 and then multiply. On the top, we are going to have the ratio of the compound we want. So that would be 2 moles Fe2O3. And on the bottom, we are going to have the compound that we were given the moles for, including the coefficients. So 3 moles CO2 And now moles CO2 cancel out. So I'm going to multiply 0.20 by 2 and then divide by 3 to get 0.13 moles Fe2O3. So now we're going to move on to mass stoichiometry. And I've kind of written out some steps that I learned and I used from the notes that I had when I was learning honors chemistry. And we are kind of just going to go through them with an example problem. So our first step is going to be to write the balanced chemical equation, because this is really important for mole ratios to make sure you have the correct coefficients, which show the correct ratio. Then I like to draw a table. You don't have to do this, but I draw a table with one row for moles, one row for mass, and one row for molar mass. And then you are going to determine the given information, and I like to write it in the correct row of the table and determine what the question is asking for. Then you are going to calculate the molar mass of each chemical, and for this, make sure you do not use the coefficients. So if you have 2 NaCl, you ignore this 2 when calculating molar mass. Then you are going to calculate the moles present given the mass, and that would be the moles of the compound you are given the mass for. And then you can use those moles and do mole ratios like I did earlier, using the ratios of the compounds in the equation to find the mass of whatever product or reactant you need. And those are the last 2 steps. So we're going to do these steps with an example. So we have ammonium nitrate decomposing into dinitrogen monoxide and water. So ammonium nitrate would be NH4 plus and NO3 minus, and that would decompose into dinitrogen monoxide, so that'd be N2O and H2O. So now let's do part A, write a balanced chemical reaction. So because the polyatomic ions like ammonium and nitrate are not present on the product side, when I'm balancing my reaction, I'm not going to keep them together. I'm going to separate them into nitrogen, oxygen, and hydrogen. So I'm going to balance with a chart. We have nitrogen, hydrogen, oxygen. So on the left side, we have 2 nitrogens, 4 hydrogens, and 3 oxygens. On the right side, we have 2 nitrogens, 2 hydrogens, 2 oxygens. So I'm going to first try to fix the hydrogens by putting a 2 on H2O, which will give me 4 hydrogens and 3 oxygens, and that balances our equation. So part B says determine the mass of each of the products if 45.7 grams of ammonium nitrate decompose. So I'm going to rewrite my equation, making sure to include the correct coefficients. Then I've completed step 1. Next, I'm going to draw my table. And you're going to want to make sure you have your periodic table and your calculator. So I'm going to make my columns, moles, grams, and molar mass. So now I'm going to input the information I have. So I have 45.7 grams of ammonium nitrate. So I'm going to put that in this column. So now we are calculating the mass of each of the reactants. So I'm going to put a little question mark here. And now we are going to move on to our next step of calculating the molar mass of each chemical. Let's start with NH4NO3. So I have 2 times 14.01 plus 4 times 1.008 plus 3 times 16. That equals 80.052. For N2O, I have 2 times 14.01 plus 16 equals 44.02. And then finally for H2O, I have 2 times 1.008 plus 16, which is going to get me 18.016. And remember, I did not include the coefficients. Only use the subscripts. Okay, So now let's move on to our calculations. We are going to determine the moles of NH4NO3 given the mass. So if I start with 45.7 grams NH4NO3, I'm going to convert that into moles. So I'm going to put the grams on the bottom and moles on top because I'm multiplying by molar mass, but technically dividing by molar mass because the mass is on the bottom. And I'm going to get 0.571 moles of NH4NO3. And I'm going to put that in my table. Now, the next step is to use the moles of the given reactant to calculate the moles of the whatever you're looking to get the mass of. So that would be N2O and H2O. So I'm going to do N2O first. So I have 0.571 moles NH4NO3 times 1 mole N2O over 1 mole NH4NO3. And that equals 0.571 mole N2O. Next, I'm going to calculate moles of H2O by writing out what I'm starting with. And then we have to be careful because there are 2 moles of H2O per 1 mole of NH4NO3. So I'm going to multiply 0.571 by 2 to get 1.14 moles of H2O. So I'm going to write that in my table. Okay, now our last step is to use the moles and the molar mass to determine the mass of the chemicals that the question is asking for. I don't have any more room here, so I'm going to move over here. Okay, so if I have 0.571 moles of N2O, I'm going to multiply by the molar mass, which is 44.02 grams over 1 mole of N2O. And that is going to get me 25.1 grams of N2O. Now let's calculate mass of H2O. So we have 1.14 moles H2O times 18.016 grams over 1 mole H2O. And I'm going to get 20.6. Okay, so now we have completed this problem. And if we check with the law of conservation of mass, it still applies because if we add the mass of the products, which is 25.1 plus 20.6, we get 45.7, which is our original mass of the reactant. So that does work as a checking mechanism for basic stoichiometry problems, but you cannot just find the mass of N2O and then subtract that from the total to get the mass of H2O. You need to show all your calculations. Now, just a note, you could convert the moles and the mass conversion all into one if your teacher allows it and if you feel comfortable doing so. So for instance, let's say I wanted to calculate mass of N2O straight from the moles of NH4NO3. If I start with 0.571 moles of NH4NO3 and I do 1 mole N2O over 1 mole NH4NO3, I can go straight to mass by writing 1 mole N2O on the bottom of this conversion fraction and then 44.02 grams on the top. And as you can see, these units cancel out and these units cancel out. So we end up with the same answer. So now you're going to try some individual practice. So if you consider this reaction, B2H6 plus O2 yields HbO2 plus H2O, you're going to balance the reaction and then calculate the mass of HbO2 that will be produced from burning 35.6 grams of B2H6 and how many moles of H2O are produced from 35.6 grams of B2H6. So give that a try, and then I'm going to go over the answer. Okay, so let's go over the answers for this problem. I did the conversions all separately, but I did write over here that you can combine them. So I first balanced the reaction. I did not show my chart, but I put a 2 in front of the HbO2 and a 3 in front of the oxygen. So I'm going to start by calculating the mass of HbO2 that will be produced from burning 35.6 grams of B2H6. So I calculated the molar mass of everything. And now what I did was first convert the mass to moles of B2H6 and then do a mole ratio using the coefficients, because the coefficients reflect the ratio of the moles of each compound in the reaction. And then I multiplied that by the molar mass of HbO2 in order to calculate how many grams of HbO2 are reacting. And if you wanted to do this reaction combined, you could start with the grams of B2H6. I'm just going to show you how to do it starting from the moles of B2H6. So let's say you wanted to combine it, you would start with 1.29 moles B2H6 and then multiply by 2 moles HbO2 over 1 mole B2H6, and then multiply that by the molar mass of 43.818 grams over 1 mole HbO2. And you would still get the same answer of 113. And if you look, these units will cancel out, so you will be good to go. Okay, so for the second part of the question, how many moles of H2O are produced from burning 35.6 grams of B2H6? So I converted the grams of B2H6 into moles again, and then multiplied that by the mole ratio of H2O. So there are 2 moles of H2O per 1 mole of B2H6 in the reaction. I think I forgot to mention putting a 2 in front of H2O when I said how I balanced the reaction. But same kind of thing, we're just going to multiply 1.29 by 2 and get 2.57 moles of H2O. Forgot to write that in my table. And I slightly messed up on the sig figs in my table, so that would need to be like that. So now we have finished the example problem, the individual practice. Hopefully you were able to understand that. If not, don't worry, we're going to be doing a ton of stoichiometry practice, so it will for sure eventually come to you. Just make sure that you stay consistent with the ratios of each compound in your reaction, which means you have to make sure you balance the reactions correctly. So I hope you enjoyed this week's video. Next week, I'm going to be talking about percent yield, which is a slight advancement from basic stoichiometry, but is going to use the same kind of things I talked about in this video. So if you would like to learn about percent yield or need some more help with that topic, feel free to join me next week. If you have any comments or questions, feel free to leave them in the comments below, and I will do my best to answer them. I hope you enjoyed this week's video, and good luck with learning the rest of your chemistry.